Hi, I'm Andy and this is question 6 on the AQA Core 4 paper from June 2015. For more questions on this exam paper, click the I in the top right corner. In question 6, we're told the points A and B have these coordinates and the line L passes through A and has this equation here. And in part A, we're asked to find the acute angle between L and the line AB. So to find the angle between two vectors, we use this formula up here that says if we do A dot B, that's equal to mod A mod B cos theta. So here's the information given in the question, and first of all we need to find out what the vector AB is equal to. And to find AB, we do minus OA plus OB, which is the same as OB minus OA. Now in the exam there's absolutely no point in actually writing down this step unless you really want to. You just need to write down the calculation that you're going to do. So we get OB using the coordinate of B. OB will be the vector 5 minus 2, 4. And we're going to subtract OA, which will be 3, 2, 10. 5 minus 3 is 2, minus 2 minus 2 is minus 4, and 4 minus 10 is minus 6. So in our formula up here, we'll let A be equal to 2 minus 4 minus 6. And we'll let B be the direction that line L is travelling in. And to get the direction part of this equation, we use the part here, the second part that's multiplied by lambda. So that's going to be 3, 1, minus 2. So rather than just doing this formula in one go, it's often useful to just do A dot B first. And the reason for that is that sometimes when you do A dot B, you get 0, which means they're at right angles, and then there's no point in calculating the mod parts. So we're going to have 2 minus 4 minus 6, dotted with 3, 1 minus 2. So to do A dot B, we multiply the x parts, the y parts and the z parts, and then add everything together. So we've got 2 times 3 plus negative 4 times 1 plus negative 6 times negative 2. So that gives us 6 minus 4, which is 2, and then add 12, which is 14. So now that we know that's not 0, we'll do the rest of the calculation. So we can say that 14 is equal to mod of A, which we get by doing Pythagoras, multiplied by mod of B, multiplied by cos theta. So let's put all this into our calculation and see what we get. So mod A times mod B gives us 28. So we can say that 14 equals 28 cos theta. Dividing through by 28 gives us cos theta equals a half, which means that theta is going to be 60 degrees. In part B, we're told the point C lies on L such that the angle ABC is 90 degrees, and we're asked to find the coordinates of C. So to do this question, it will be useful to draw a diagram. We know A and C are both on line L, so we can put that in there. We know the coordinates of A are 3, 2, 10. And we know the coordinates of B are 5, minus 2, 4. We don't know the coordinates of C. But what we do know is that there is a right angle between AB and BC. And that tells us that if we do the dot product of AB with BC, we will get 0. So AB we already know from earlier is 2 minus 4 minus 6. But we don't know C, so BC will have to be written as an expression. So to get BC, we would do OC minus OB. Now we already know OB, we don't know the value of OC, but what we do know is that it's on line L. So we can write an expression for OC. So on the right here, the line equation for L has magically appeared. So for OC, we're going to write down this equation here with a different letter for the parameter, but I'm also going to combine it together into a single bracket at the same time. So I'm going to have 3 plus 3 lambda, but I'm going to use the letter T. So that's going to be 3 plus 3t. We're going to get 2 plus 1 lot of t, so just 2 plus t. and I'm going to get 10 minus 2 lots of t. And then I'm going to subtract OB from that. B's up here, remember, so that's going to be 5 minus 2, 4. And if I combine that all together to get a single bracket, I get 3 minus 5 is minus 2, so 3t minus 2. I get 2 minus minus 2, which is 4 plus t. And I get 10 minus 4 is 6 minus 2t. So now that I've got an expression for BC and a value for AB, I can do the dot product. So I've got AB, which is this, dotted with BC, which is my expression. And this is going to equal 0. So we have 2 multiplied by 3t minus 2, minus 4 multiplied by 4 plus t, minus 6 multiplied by 6 minus 2t. Expanding out the brackets, we get 6t minus 4 minus 16 minus 4t minus 36 plus 12t. 6t minus 4t is 2t plus 12t, that's going to give us 14 lots of t, and we've got minus 4 minus 16, that's minus 20, minus 36 gives me minus 56. So adding 56 and dividing by 14 gives me t equals 4. Now that I know the value of t, I can just use that in my equation up here to find OC, and I get 3 to 10 plus 4 lots of 3, 1 minus 2. 3 plus 12 is 15. 2 plus 4 is 6. 10 minus 8 is 2. So the coordinates of C are 15, 6, 2. In part C, we're told the point D is such that BD is parallel to AC, so it's going to be somewhere down here. And angle BCD is 90 degrees, so an angle between B, C and wherever D is, that must be 90. And the point E lies on the line through B and D such that the length of DE is half that of AC. There's a lot of information to digest in one go here. The best thing to do will be draw a diagram and put things on piece by piece. In the end, we're trying to find the coordinates of the 2 possible positions of E. So here's my diagram from the last part of the question, and we're going to add all the information on now. We're told that D is on a line that's parallel to AC. So if we just draw a line AC here, we can then move it to make it parallel. It's going to be somewhere along this line. It could maybe even go in the other direction up here until you look at the second condition. So it says that BCD must be 90 degrees. So BCD must be 90. That means if we draw a line across here, we can find out where point D is. And then we're told the point E lies on that line such that the length DE is half of AC. So let's start with a line that is half the length of AC, which would be roughly this long. So if we put that on point D, we have one point where E could be here. We'll call this E1. But we have another point, still on the same line, that it could be down here. Remember, the only conditions are that it must be on this line and it must be this distance away from D. So next we have to think, how are we going to get to one of these positions here or here from the origin? And to do that, we're going to use points we already know. So we know A, we know B, and in the last part of the question, we found C is 15, 6, 2. We don't know D yet, and obviously we don't know E because that's what we're trying to find. So to get to E1, what I'm going to do is start at the origin, and I'm going to travel to B, which I know the coordinate of, and then I'm going to travel along this line B to get to E here. Now the only point I know on this line at present is B, so I don't know E or D, but what I do know is that it's parallel to this line here, AC. So to get the vector BE1, all we would need to do is take the vector AC and multiply it by half, because this vector here is half the length of it. So to get from O to E1, we need to go from O to B, just the position vector of B. plus BE1. But because we know BE1 is half of AC, we can write this as OB plus half of AC. So that means in order to answer this question, we first need to figure out the vector AC. To do that, I just need to do OC minus OA. I won't write down the calculation, we'll just do it on the fly. We've got 15 minus 3, that's going to be 12. We've got 6 minus 2 is 4. And we've got 2 minus 10 is negative 8. So to find E1, we're going to have 5 minus 2, 4. Plus a half of 12, 4 minus 8. 5 plus 6 is going to give me 11, minus 2 plus 2 is going to give me 0, and 4 minus 4 is going to give me 0. So E1 will be the coordinates 11, 0, 0. We can do something very similar to get to E2. We're going to follow the same path. We're going to go from O to B plus B to E2. But calculating B to E2 will be slightly different to calculating B to E1, because rather than just half of the distance from A to C, we want to go the whole distance and then another half. So we want to multiply AC by 1.5, or 3 over 2. So this time we're going to have 5 minus 2, 4, the same as last time, plus 3 over 2 multiplied by the vector AC, which we calculated as 12, 4, negative 8. And that's going to give us 5 plus 18, which is 23, minus 2 plus 6, which is going to give us 4, and 4 minus 12, which is going to give us minus 8. And that means that E2 will have the coordinates 23, 4, negative 8.